Hooray! I have the keys to unlock Pocket Ronnie. Alright, we're going to be graphing hyperbolas. Hyperbolas have two parts to them in their graph. So just to show you in general what a hyperbola looks like. So a hyperbola, when the equation looks like this, x times y equals a plus or minus number. So basically it's going to be x times y, xy equals a positive number or xy equals a negative number. So hyperbolas have two parts and they are a mirror image of each other. When your equation looks like this, it's either going to be graphed in quadrants 1 and 3, and these are a mirror image of each other, or it's going to be graphed in quadrants 2 and 4, and again, those are mirror images of each other. I did not draw those very well of mirror images, but they are mirror images of each other. So that is what a hyperbola looks like, but they're, just so you know, there's two parts. Oh, one other thing I wanted to point out with these is that a hyperbola, when the equation looks like this, x times y, it will never cross the x or y axis. This will continue to get close to the x-axis, but never cross. This will continue to go up and get really, really close to the y-axis, but never cross it. Okay? So, also on hyperbolas, one thing you will notice is that neither x nor y is squared. The same is true in a line. In a line, neither x nor y is squared, but in a line, x and y's are added together, added or subtracted. In a hyperbola, x and y are multiplied together. That's how you know the difference between a hyperbola and a line. In a hyperbola, x and y are multiplied together. This is just one, the reason I have it number 1, this is just one general form of a hyperbola. So let's look at 26b, number 2. You have this equation, 0 equals 4 minus xy. We should put it in the form, the general form that I showed earlier. So we want x and y on one side and the whole number on the other. So I don't want this negative, so I'm going to add my x and y over here. So x and y are connected together. So then I would have xy equals 4. From my notes before, xy equals a positive number. Since this is a positive number from my notes before, this will be graphed in quadrants 1 and 3. So just as a rough sketch, then I know that this hyperbola is going to be graphed in quadrants. Remember, this is 1, 2, 3, 4. Okay? The quadrants are counted in a counterclockwise direction. So when this is a positive number and it's in this form, it will be in quadrants 1 and 3. So the larger this number is, the further away from the x and y axis your hyperbola is. So, but you know, you're never going to be able to get a complete detailed graph. That's what computers are for. So for the level of this class, for Algebra 2, it's okay just to have a rough sketch. We are going to plot a few points just to sort of get an idea of how the graph looks like. So again, you can plot points. So, okay, one thing I want to point out, when you have the equation of xy equals 4, that your hyperbolas, when it's in this format, it's never going to cross the origin. Your graph is never going to cross the origin, or it's never going to cross the x or y axis, which means neither x nor y can be 0, because if I plugged in 0 for x, okay, that means 0 times y, 0 times anything is 0, and 0 equals 4, and that's not a true statement. And the same is true if we try to put in 0 for y, okay? So you will never be using 0 to plug in values to try to find coordinates. So you're going to have to use numbers other than 0. So, okay, let's just say if I put in 1, let's just do 1 for x. So if I plugged in 1 for x, 1 times y is just y, so y equals 4. Okay? So what if I put in -1? Remember, they are mirror images of each other. So if I put in -1 here, then I basically, let's just say I'm going to divide both sides by -1, then y equals -4. Then I'm going to have the mirror image of that. Alright, so let's just plug in 2. So putting in 2 for x, that would be 2 times y equals 4. I got to divide both sides by 2 because these are being multiplied. So then you can see y is going to equal 2. Okay, well what if I plugged in -2 for x? Okay, then I'm dividing both sides by -2. Then y would equal a -2. So putting in -2 for x gives me a -2 for y. So let's just say if I plugged in 4. So putting in 4 for x, dividing both sides by 4, that's going to give me a 1 for y. What if I plugged in a -4? Now dividing over here by -4, 4 divided by -4 would be a -1. So these are just some points that you can plot. This is a good rough estimate of the graph, and then you can go plot these points to try to get a little bit more detailed. It will still be an estimate in some ways because you're not going to plot points all the way out, you know, to get very, very close to the x-axis or the y-axis. Okay, we're graphing 26b2. The equation was xy equals 4. Since 4 is a positive number, that tells me that my hyperbola is in quadrants 1 and 3. So when this number is positive, it's going to be graphed in quadrant 1 and 3. So instead of just doing a rough sketch, we plotted out some points. So our points were 1 and 4. So over 1, 1, 2, 3, 4. -1, and then down 4, 1, 2, 3, 4. Remember, these are mirror images of each other. So, and then 2, 2, 1, 2, 1, 2, -2, -2, over 4, up 1, 1, 2, 3, 4, up 1, 2, 3, 4. And then -4, -1, 1, 2, 3, 4, -1. And you can kind of see you're starting to get the shape of a hyperbola. Remember, hyperbolas, when the equation is in this form, you are not going to cross the x or y axis. So you're just going to be getting close to the y-axis and then getting close to the x-axis. And again, these are mirror images of each other. And so it should look something like that. Now we're looking at 26D, 1 through 2, 1 and 2. So you have this equation here. We want to put it in the form, in the general form that I've given you, to where x and y are multiplied together on one side and your numbers are on the other side. So I can multiply, if I multiply both sides by y, multiplying this by y, my y's cancel. If I multiply y to this side, I have to multiply it to this side. So the y's cancel. So I'm just going to switch the order. Y times x is the same thing as x times y because they're commutative. Multiplication is commutative. Now it's in the general form. Because this is a negative number, it means that when you go to graph it, you're now going to be in quadrants 2 and 4. The bigger the number is, the further away from the x and y axis you are. So it could look something like this. And remember, they're mirror images of each other. I'm doing the best that I can of drawing a mirror image. You're never going to cross the x or y axis. So mine aren't exactly mirror images, but I'm not drawing it as well. But they are mirror images of each other. And this is in quadrant 2 and quadrant 4. You can plug in some points and plot a few points to get a little bit more detailed, but at this stage of the game of Algebra 2, this graph is a close estimate. I will not be graphing this on graph paper for you for this video. Okay, hyperbola equations can also take another form. They can take the form of this. Remember, a and b are coefficients, so hyperbolas can take the form of x squared minus y squared equals some number. So, and these are just coefficients in front of your x squared and y squared terms. Remember, circles and ellipse both have an x squared and a y squared term, but the difference between a circle and ellipse, a circle and ellipse have a plus sign here. Hyperbolas have a subtraction sign with an x squared and a y squared term. When your x squared term is first, when you have x squared minus your y squared, your hyperbola is going to look like a C and a backwards C. In other words, it's going to take this form right here. It will be crossing the x-axis like this, and again, they're mirror images of each other. So the hyperbola could be, it's like having two parabolas basically, but they will cross the x-axis, and that coordinate has some sort of x coordinate, and then the y coordinate is 0. So that's important to know that. So in the shape of your hyperbola, it could be very rounded like that, or it could be very open like this. So I just in general call that a C and a backwards C, just so you get an idea of what it looks like. Alright, let's look at one of these on 26C, 5 and 6. You have this equation here, but to get it in a general form, you need your x squared and your y squared on the same side. So we're going to subtract my y squared term over here. I can't combine x squares and y squares, so I'm going to write it like this. And then I can see that my x squared term is first. When x squared is first, then it's going to be a C and a backwards C. It will look different when your y squared term is first. So when x squared minus y squared, then it's going to look like a C and a backwards C. So what we want to do is, we know the hyperbola is going to cross the x-axis, and at that point your y coordinate is 0. So we want to let y equal 0. When y equals 0, this whole term goes away and becomes 0, and then you're just left with 2x squared equals 6. What we are trying to do is calculate the point at where the hyperbola crosses the x-axis. So now we solve for x. So divide both sides by 2. So now we have x squared equals 3. To solve for x, take the square root of both sides. When I take the square root of both sides, what do I put in front of my radical? A plus or minus. So now I know that x is a plus or minus, and I'm going to put approximately square root of 3, rounded is about 1.7. I need to know, I need to put it in decimals in order to graph it. So I now know, if I make me a little XY chart, that when y was 0, that I've got a plus or minus 1.7. That's where I'm going to be crossing the x-axis. Okay? So I can plot a few other points as well. So again, you just take your equation, the 2x squared minus 2y squared equals 6, and I'm just going to pick points for x. You can pick points for x or y, it doesn't matter. I'm going to say, well, when x was 2, I'm just going to pick x equals 2. I'm just trying to pick small numbers because I'm going to see I can square it. So if x is 2, I'm trying to solve for y. So 2 squared is 4, 4 times 2 is 8, so that's 8 minus 2y squared equals 6. Subtract 8 from both sides, so that would give me a negative 2y squared equals 6 minus 8 is negative 2. Divide both sides by negative 2. Oh, that becomes a positive 1. I should cancel that out, but y squared equals a positive 1. And negative 2 divided by negative 2 is a positive 1. I shouldn't cross that out like that. Those go away to make 1. Take solving for y, take the square root of both sides, so y equals a plus or minus 1. Put plus or minus in front of your radical. Square root of 1 is just 1. So when x is 2, I am going to get a positive or a negative 1. Okay, I can also write it like this. When x is 2, I get a positive 1 and a negative 1. I can write it like that. Okay? If you go put in a negative 2, if I go put in a negative 2 over here, I'm going to get the same answer because I'm squaring it. Negative 2 squared is still a positive 4, and positive 4 times 2 is 8. So I'm going to get the same thing when I put in negative 2. So when I put in a negative 2, I'm going to get a positive 1 and a negative 1. So those are points that I can plot on my graph just to make it a little specific. But just to give you an idea, if I just did a rough sketch here on a graph, the main thing that I need to know is, where does this cross the x-axis? It's going to cross at plus or minus 1.7. So if I just did a rough sketch, this is 1, 2. So if I go over to 1.7, x is 1.7, and I don't go anywhere in the y direction, and then I go over negative 1.7. That's where I'm going to cross the y-axis, and then it's going to look like a C. Plotting the other points will tell you more of an idea. Is it going to look more like big and rounded, or is it just going to curve over really quick? But the main thing is they're both mirror images of each other. So plotting more points tells you more specifically of how the actual curve looks like. But one of the main things you need to know is where does this cross on the x-axis. Okay, now we're graphing 26C, 5 and 6. Our equation was this: 2x squared minus 2y squared equals 6. When your x squared term is first, that tells you that it's going to be a C and a backward C. And you had to determine where are you crossing on the x-axis. The x squared term is first, so you're going to cross on the x-axis. So that's when y equals 0. So we found that we're going to cross the x-axis at a positive 1.7 and a negative 1.7. So if you go over 1.7, don't go up anywhere in the y direction. And then a negative 1.7, we're going to cross the x-axis there. And it's going to be a C and backward C, but we calculated a few more points to plot. So when x is 2, 1, 2, then we found that y is a positive 1 and then also a negative 1. So we have those points. We also, it's a mirror image, so when x is negative 2, you also have a positive 1 for y and a negative 1. So from here, you'll just kind of have to estimate about how much it's going out, but they are mirror images of each other. So you just do the best you can at doing a mirror image of each other. Okay, hyperbolas can take a third general form. The second form was when x squared was first. Now the third form is where y squared is first, where we have a y squared term minusing an x squared term. Remember, hyperbolas have a subtraction sign. Ellipses and circles have a plus sign with an x squared and a y squared term. Hyperbolas have a subtraction sign. When your y squared term is first and it's y squared minus x squared, your hyperbola is going to look like a u and a, not backwards, but upside down u. So in other words, when your y squared term is first, it's going to cross the y-axis. So I will be crossing the y-axis and it will look something like this. Or it could be very wide, like that. You plot more points to look more specifically at what it's doing. But it's important to find out where does it cross the y-axis. Where it crosses the y-axis, our x-coordinate is 0. So we want to let x equal 0 in our equations to figure out what this point is. So let's look at one of these at 26b6. Since we have our y squared term first, this tells me it's going to be a u and an upside down u. So in order to find out where I'm crossing the y-axis, I have to let my x equal 0. Because on the y-axis, my x-coordinate is 0. So when x is 0, that whole term goes away. Because 0 squared is 0 and 0 times anything is 0. So then the only thing we have left is y squared equals 16. We solve for y by taking the square root of both sides. When we have a radical, we put plus or minus in front of it. So y equals plus or minus 4. So making out our little xy chart, we said when x is 0, y is going to be plus or minus 4. That tells us where we're crossing the y-axis. So if I just had to sketch a rough sketch right now, 1, 2, 3, 4, 1, 2, 3, 4, then right now I'll cross the y-axis at, I don't go anywhere in the x direction, and then I go up 4 and down 4. So right there and right there. And then so my hyperbola is going to look something like this, but I can plot more points to specifically get an idea of what my curve looks like. Is my curve wide or is it narrow? So I'm just going to do one more point. If I plugged in, I picked 2 for x. So if I come over here to my equation and I put in 2, for x. 2 squared is 4, and 4 times 2 is 8. So that's y squared minus 8 equals 16. Add 8 to both sides. So that's y squared equals 24. So taking the square root of both sides, put a plus or minus in front of there. So in my calculator, so the square root of 24 is roughly 4.9. So when x equals 2, I got a plus or minus 4.9 for my y value. And so I can plot that point to look more specifically at what my graph is doing. Okay, now we're graphing 26b6. We have y squared minus 2x squared equals 16. Our y squared term is first, which tells us we will be crossing the y-axis, which means we will have a u and an upside down u. So first you had to determine where you are crossing the y-axis, which meant letting x be 0. So we're crossing the y-axis at a positive 4 and a negative 4. So right there, and 1, 2, 3, 4 there. Again, you can just do a rough sketch from there, but we calculated a few more points. So we said at positive 2, we were up at 4.9. So 1, 2, 1, 2, 3, 4, almost at 5. And then negative 4.9, 1, 2, 3, 4, almost at 5. And then same with negative 2 because it's a mirror image. So, and it's symmetrical about the y-axis. So at negative 2, we were up at almost 5. And at negative 2, we're down at almost 5. So this just gives us a little bit more idea that our hyperbola is going to be something like this, and remember they're mirror images of each other.